So in this module, we're going to talk about really, we should be using big data, but what are the challenges of big data, right? And we'll explore one aspect of it. There are so many other aspects. We could spend a lot of time about it. We're going to talk about something called the curse of dimensionality. It's, if some of you have seen Monk, it's a curse, but it's a gift, right? So if you haven't seen Monk, you should go and see Monk and understand what's a curse and a gift at the same time, right? So in this module, we're going to talk about four things. The first, why does this issue of more data come up, right? And it comes up because of different types, the way they're organized, and why multiple channels of communication, we may be getting inputs from many different channels, and we are trying to coordinate them. So that's part of the data complexity issue, right? Now, increasing complexity, does it give benefits? We already saw, for example, in the car example, car price example, we said, look, there could be in the future a variable, which is the condition monitoring of the car, which is available to you. Can you use it? How can you use it? How much extra value does it give when you're pricing a car? So why do we call it a curse? We're going to talk a bit about it and talk about some very simple ways of taking care of the curse. And finally, we're going to say, okay, if our objective is to extract meaning from a data like this, is there some tool, some method which will help? And we will talk about very simple methods like a scatter plot and more complicated methods. It's only one I'm going to explain, but I'll at least name a few more which you can go and read about in the references to this module. You might have seen this chart somewhere. Somebody would have already said that what has changed about big data is the velocity with which it is coming to you, the volume to which it's coming, the variety of data which is available, and also the veracity of it with the fake news and all, right? And some data you can trust, and some is verified, and some is triple verified, okay? So given that, we know that data comes in so many different ways, okay? And this is one way of thinking about it, but there are more precise ways of looking at it. Data comes in numbers. So you've seen numbers already. You've seen statistics. You've seen weight. You've seen maybe distributions. So we have seen data, numeric data of all kinds of things. Now, data also comes in what we call ordered fashion, but the different classes are not equidistant. So you could have small, medium, large. You could have low, medium, high income bucket, right? You could have how relevant the data is, not very relevant, more relevant, most relevant, right? So there is an ordering. And there is another kind of data, which is symbolic, where there's no order. You're red, green, and blue, right? There is a state and a country and a region. So basically, there are ways in which you can just label things. So these are labels, right? So what we saw was different types of data. Clearly, data also differs, as you would have seen in your first and course, in how they are stored. So the common way is to store them as a table, rows and various features in tables. In fact, all the data we have explored so far are of that kind. They're tabular, right? Or there could be a basket, like a shopping basket of data, a market basket, right? Or a list of keywords. Now, what's the big difference? That this is a high-dimensional, highly sparse data compared to a table. A table has got very few dimensions, and it's very dense compared to a basket of items that you purchase. We will see that in one of our examples in one other module. Another kind of data is simply whatever you got in your bag. 3 eggs, 4 cereals, right? 2 soap bars, 5 milks. We could do the same thing with a document and say, okay, does this document have 5 words which say you win and 3 words which say immediately and 10 times it says it's lucky and you know it's a spam, right? Compared to a document which says you are requested to be at such and such a place for such and such a meeting, right? So you can have meeting mentioned once, you mentioned once, a place mentioned once. So the bag of words is meaningful depending on what it contains. So we could organize data in different ways. So you have different types of data and different types of ways of organizing. So the bag of words is considered a high dimensional and sparse data. Moving on, data. And my colleague who shared some of these slides with me, he uses the word modality here. I'm using the word structure here. Data could be structured in the sense it could be in fixed columns, right? It could be numeric, it could be symbolic, whereas data could be unstructured. So it could be a speech, like what I'm doing. It could be a ticker symbols moving. It could be a text document, right? So just look at the complexity now. Your types of data, how they're organized, how they're structured, creates a sort of variety in which we can use to do the same classification, prediction. Okay. So the question for us is more better. Obviously, we would like to believe it is, right? But we run into 2 problems. First problem is distance. So if your data, your predictor variables are categorical, how do you model distances? Okay. It becomes a problem because for categorical variables, distance is not well defined. The other problem is now, on top of it, I add text. So I have numerical variables, I have categorical variables, I have text. How do I even model something with it? So obviously, I have to find a way of extracting the features in the text and making it in a nice modelable format so that then I can predict. What we are really going to, we are asking is more better. Now this is a case study shared with me by the same person who is now one of the top machine learning experts with one of the big companies in India. And he said in his first job, right, he saw this example. So you see a graph here. There's a line in black and a line in red, and basically it is, if it is higher, it is better. So the first part, the bank wanted to predict whether calling a customer would help in improving collections of a loan. So if you use just the numerical variables, there was a bit of accuracy. But what my friend, his name is Shailesh Kumar, found was, let us say I recorded the call center conversation, right? And I looked at the notes that the call center representative was making and extracted information from the text and added it to the numerical variables. My prediction accuracy goes up, okay? So the idea being that, yeah, more is better, right? But how much more? That's the question we're trying to ask.